Hey everyone, and welcome to this explainer on Canadian Electrical Code Section 12. I'm your host, and today I'm fully stepping into the role of your Red Seal exam trainer. We're going to take those dense, sometimes incredibly dry Raceway rules and turn them into practical, real-world job site knowledge. We are going to break this code down into simple, everyday language so you can actually use it out in the field and absolutely crush that exam. So let's take a really quick look at today's lesson plan. We've got 5 parts: navigating basics, the rules of the pull, separation and hazards, a red seal simulator, and a summary and final review. Basically, we're walking you through the entire life of a conductor, from prepping the pipe all the way to job site hazards. My goal is to make sure you know exactly what the rule is, why it exists for your safety, and how to spot those sneaky traps examiners love to throw at you. All right, let's kick things off with Part 1, Navigating Section 12 Basics. We're starting with the foundational rules of putting wire into pipes safely, beginning with how we actually group our circuits. Take a look at Rule 12-904. The code states that all insulated conductors of a circuit must be contained in the same raceway. Now, out on the job site, what does that actually mean? In simple terms, it means you cannot, under any circumstances, split up the conductors of a single circuit into different pipes. Why? Because if you do, it creates this intense, dangerous magnetic heating in the metal raceway. Your phases and your neutral absolutely have to travel together, so their magnetic fields cancel each other out. If you split them up, you literally turn your conduit into a giant induction heater. Not good. And if you're ever wondering, just how many total wires can I legally pull into a single conduit? Well, Rule 12-910 has a strict, hard cap. It's exactly 200. Now, obviously, that's assuming you don't exceed the overall fill limits in Table 8. But for your multiple choice questions, burn that number into your brain. A maximum of 200 wires is a super quick, easy point to score on the exam. Moving right along to Part 2, the rules of the pull. Let's transition to the physical procedure of step-by-step preparation, treating this just like a real job site operation. Here we go, the journey of the perfect wire pull. Step 1, Rule 12-938. You have to build the complete system first. Seriously, no pulling wire through a half-built pipe while the framers are still working around you. Step 2, Rule 12-922. You've got to remove the burrs and ream those sharp edges. Step 3, Rule 12-906. Add insulated bushings. If your wire is a number 8 AGG or larger, it has to be stranded, and it absolutely requires an insulated bushing to protect it from scraping. And finally, Step 4, Rule 12-908. Only apply approved lube. We're talking pulling compound, talc, or soapstone, so you don't accidentally eat away the wire insulation with unapproved harsh chemicals. Now, why does Rule 12-942 limit us to a maximum of 4 90-degree bends between draw-in points? It all comes down to friction. Any more friction than that, and you will literally snap the conductor insulation right off the copper from the sheer pulling tension. That risks a massive arc or even a fire. So just use this easy memory trick. 4 bends, and you're at the end. What's really fascinating here is how Rule 12-902 handles armored cable when it's installed inside a conduit. You might think it's all treated exactly the same, right? But notice how aluminum gets way longer permitted runs. For instance, a 3-conductor copper cable maxes out at 15 meters. But a single-conductor aluminum cable, you can pull that up to an incredible 100 meters. And that's simply because aluminum is significantly lighter, which causes way less sidewall bearing pressure dragging against the pipe during the pull. Let's jump into Part 3, Separation and Job Site Hazards. Let's see what happens when our perfectly built raceway hits the harsh reality of an active construction site. Okay, read Rule 12-912. The memory trick here is simple but crucial. Bury the splices, lose your licenses. You can never, ever hide a wire joint inside a pipe. A conduit is for transport only, not for making connections. But you've got to keep a sharp eye out on the exam because the code does try to trick you. There are a couple of exceptions where splices are allowed, specifically in cable trays and in surface raceways that have removable covers. The second your raceway hits dirt or concrete, moisture and galvanic corrosion become your absolute worst enemies. Rule 12-922 says you must seal underground building entries to stop gas and moisture from flooding straight into the electrical room. Rule 12-930 classifies concrete slabs in direct earth contact as Category 1 moisture locations. And pay attention to Rule 12-96 because it's a huge safety trap. Never put bare aluminum raceways directly in concrete unless it's painted with a bituminous base paint or the concrete has 0 chloride additives. The chlorides in standard concrete will completely dissolve bare aluminum over time. It'll eat it for breakfast. All right, it is time for Part 4, the Red Seal Exam Simulator. Let's test your knowledge and see if you can spot the code traps before exam day. Here is a classic textbook code trap regarding mixing different power sources and voltages in one single pipe. Take a really close look at the scenario. You've got a high voltage motor feed and a low voltage control line. So what's your call? Is it A, yes always? B, no never? C, yes if separated by metal armor or a 1.34 millimeter steel barrier? Or D, yes if they are both copper? Take a quick second. Think back to that separation of voltages rule we discussed earlier in Rule 12904. If you guessed C, you nailed it. The crucial point here is safety. Why does the code demand this? Well, if that 600-volt conductor's insulation fails and shorts out to the 120-volt line, you will absolutely blow up the controls, and you could seriously injure the operator touching the stop button. That is exactly why a 1.34 millimeter physical steel barrier or metal cable armor is legally demanded to keep them safely apart. Now, let's troubleshoot a very real job site failure that you might actually encounter as a scenario-based question on your exam. Imagine you pull a large number 3 stranded wire out of a pipe and it is completely chewed up. The insulation is just shredded. Which combination of physical preparation failures turns your Raceway into a literal cheese grater? Look closely at the options and find the rules that specifically deal with the physical ends of the pipe. And B is correct. This brilliantly illustrates why we always say the code is written in blood. Failing to ream your pipe to remove those burrs under Rule 12922, or completely forgetting the proper insulated bushings for a wire size number 8 or larger under Rule 12906, directly results in shredded wire, and that creates a massive ground fault hazard. Okay, one last quick check on our hard limits for pulling tension before we wrap things up. This is a straight-up memorization question that you want to be able to answer in about 5 seconds, so you can save your valuable time for the harder calculation questions on the exam. Is it 2, 3, 4, or 5? Think back to that hard cap we threw on the screen just a few minutes ago. The answer is C. Remember the mnemonic? 4 bends and you're at the end. Keep that in your back pocket so you can instantly answer this without even needing to flip open your codebook and hunt down Rule 12-942. Finally, we made it to Part 5, Summary and Final Review. Let's lock these key takeaways into your brain for good before you hit the books tonight. If you only take away one single thing from this entire explainer, make it this list right here. Seriously, take a screenshot right now. Memorize these 5 simplified rules. Keep all serpent conductors in one pipe. Build the complete pipe before you pull. Prepping big wire means anything number 8 or larger needs to be stranded and requires an insulated bushing. No joints in pipes. Bury the splices, lose your licenses. And finally, tension limits mean a maximum of 4 bends. If you master these 5 concepts, you will easily navigate Section 12 on exam day. So, how did you do on the simulator? Before you head back to the site, hit that like button, comment your score down below, subscribe for more Red Seal code breakdowns, and definitely share this explainer with a fellow apprentice who needs to brush up on their Raceway rules. But before you go, I want you to think about this. If we max out our bends and our wire fill, how much does that actually derate our ampacity? Well, we'll tackle that exact code trap next time. Stay safe out there. Class dismissed.